So now we will be studying about the wave theory of an atom. So after the drawbacks of the Rutherford model, a new theory was put forward to understand the movement of electrons in an atom. This was known as the wave theory. So let us first understand what is a wave. A wave is defined as the periodic disturbance that is caused in a medium and which can carry energy or other forms of energy. Now this wave depends upon the temperature, pressure and volume, that is the elastic properties of this medium. Now why am I calling a wave a periodic function? Because what is a periodic function is any function which repeats itself after a particular time period. So as we can see, this wave is repeating itself after a particular time period. So this is a periodic wave function. Now let us look upon some important factors or some important terms that is used in a wave. The first term is the wavelength. So before understanding wavelength, let us know some points that occur in a wave. So the highest point in a wave, this is known as the crest, and the lowermost point in a wave is known as the trough. Now this distance and this distance, I have shown this schematically, so it was not to scale, but this distance from this point to the crest or from this point to the trough is always same and is known as the amplitude of a wave. I draw it again. If this is a wave and this is the crest and this is the trough, this distance is known as the amplitude of the wave. This distance, in actual condition, the wave propagates like this. First is it has a very large amplitude, then the amplitude goes on decreasing. But we will study an ideal wave. What is an ideal wave? In an ideal wave, the amplitude does not decrease because we do not consider anything such as friction or the drag force by the air or something. So this is an air and it has a fixed wave and it has a fixed amplitude. So this distance is known as the amplitude. So what is a wavelength? Wavelength is the distance between two consecutive troughs or two consecutive crests. As I have already told you, this distance would be equal and this is a periodic wave. So the distance between two crests or distance between two troughs will always be the same and it is defined as lambda. Now the wave characteristics of an atom. The wavelength is measured in angstrom. Angstrom is a unit and 1 angstrom is equals to 10 to the power of minus 10 meters, or we can say 10 to the power minus 8 centimeters. The second important term in a wave is frequency. So what is the frequency of a wave? Frequency of a wave is defined as the number of waves which pass through a point in 1 second. So if this is a wave and we take this particular point, so the number of waves that are passing through this particular point in 1 second is known as the frequency of the wave. Frequency is measured in the terms of hertz. Its unit is second inverse. How second inverse? Frequency is the number of waves passing in 1 second. So it is 1 upon time. Time is measured in seconds. So 1 upon seconds, that is second inverse. So the unit of frequency is second inverse. And 1 hertz is equals to 1 second inverse. Now what is time period of a wave? I've already told you, time period is the time after the wave starts repeating itself. So if we have considered this point and we are measuring the number of waves that are passing through this point, so if one wave passes through this point, the other wave will come after a particular time period, and which is known as the time period of the wave. Time period of the wave is the inverse of frequency, that is 1 upon nu. So time period, the SI unit of time period would be seconds. As we have seen, the SI unit of frequency was second inverse, so 1 upon second inverse will again give us seconds. Now the fourth term is the velocity of a wave. So as we know that speed is the distance traveled per unit time, and velocity is speed with direction. So as in the case of a wave, we will just consider it to be unidirectional. So velocity and speed would be same in the cases we consider. So c is equals to distance upon time. Distance is lambda, between two crests is lambda, upon time. Time is the time period. So as we all know that 1 upon time is known as the frequency. So speed is lambda times frequency. So speed of a wave is lambda times, that is the wavelength, times frequency. The fourth important term is wave number. Wave number is the reciprocal of lambda. It is just used in numericals, so you need not to worry about itself. And the SI unit is meter per inverse. As lambda was in meters, so 1 upon lambda would be 1 upon meters, that is meter inverse. The fifth thing is amplitude. So I've already told you what our amplitude is. Amplitude of a wave is defined as the height of the crust or the depth of a trough. I've told you this. This height and this height would be same and known as the amplitude of the wave. Now frequency is speed of the wave upon lambda, that is c into wave number. Now these are the relations. You can just interchange the terms and get these relations. So some features of this electromagnetic waves is it is the energy transmitted from one body to another body in the form of waves, and these waves travel in the space with the same speed of that of the light. So what is the speed of the light? Speed of light is 3 into 10 to the power times 8 meter per second. So electromagnetic waves travel with the same speed as that of light, that is 3 into 10 to the power 8 meter per second, and they do not need any medium for propagation. So as we know that when light travels, it requires some medium. The medium in the air, the particles in the air, they absorb the light and they re-emit the light for its transmission. But in electromagnetic waves, this medium is not required. So this radiant energy, because this wave is carrying some energy, so this radiant energy from one body that is traveling towards the second body does not require any medium to travel. So I have told you about these terms. Now I'll give you a question. You pause the video and solve this question. So the question is, calculate the wave number in centimeter inverse and the frequency of light of wavelength 5800 angstroms. So you may please pause the video and solve this. So as we know, wave number is 1 upon lambda. So lambda is 5800 angstroms. Angstroms is 10 to the power minus 10. So this would be equal to 10 to the power 10 upon 5800, and this is in meters. So as we want to convert it into centimeters. So it was 10 to the power minus 10 meters. As we want to convert it into centimeters, it will be 100 times 5800 into 10 to the power minus 10 centimeters. This comes out to be 10 to the power, oh I'm sorry, I did a mistake here. So 1 angstrom is equals to 10 to the power minus 10 meters, that is equals to 10 to the power minus 8 centimeters. I'm sorry. So this would be equal to 1 upon 5800 into 10 to the power minus 8 centimeters. This would come out to be 10 to the power 8 upon 5800 centimeters, and on calculating we will get 17241.4 centimeter inverse. Now frequency is C upon lambda, C into 1 upon lambda, C into wave number. So C is 3 into 10 to the power 10 centimeter second inverse into 1.7 into 10 to the power 4. See, here we got the result 17241.4, but using the approximation I wrote it 1.7 into 10 to the power 4 centimeter inverse. And on calculating we will get a result that is 5.1 into 10 to the power 14 second inverse. If you take this value also, you will get a value close to this. So these kind of numericals are not asked, you are just asked to round off the value to the nearest integer.